So hello everyone, my name is Yu-Hui Huang. So here I'm going to introduce my research domain, that is computer vision and its related applications. So before we start, I would like to just shortly introduce myself. So last year in February, I joined YZU as an assistant professor in the Department of Electrical Engineering. So before that, I had my PhD degree in KU Leuven from Belgium. So KU Leuven is one of the oldest university in Europe and was founded in 1425. So it's located close to Brussels and it is famous for Belgium. Yeah. So that is the most important part from my talk. That is, fries were invented by Belgian people, not French people.
Okay.
So in addition
That's
to
fine.
the
Same by Belgium, is it okay? Good.
yeah. In addition to the Belgian experience, I also had my master's degree from RWTH Aachen University in Germany, and I had some research experience from National Institute of Informatics in Japan and Academia Sinica in Taiwan. So my research interests are computer vision, deep learning, and machine learning. So the recent task I have been working on is called semantic segmentation. So given the RGB input image like this, the goal of this task is to predict the pixel-wise class label like this. So from this figure, you can see that each color denotes one class, like the purple color is the road and the blue color is the car and so on. So we are utilizing different algorithms from deep learning or machine learning to improve the performance of this task in terms of accuracy or inference speed. So when it comes to computer vision, what is that? So the definition is to enable machine to understand the images or videos. So it is like we are designing the brain of the robot to let it able to see through this camera. So it is a multidiscipline subject, including so many different subjects like AI, machine learning, cognitive science, algorithms, image processing, and graphics. So here are some applications you can find in our daily lives. Like this one is Google Lens. That is a mobile app that you can search for some informations by taking the pictures from your daily lives. So it is a typical application called image retrieval. And so for the augmented reality applications, computer vision techniques are also important. So we need the task called scene understanding or semantic segmentation to make this augmented reality app working well. And Face app from Face ID from the iPhones, it is also a very important computer vision task that is called face identification or face recognition. And that one is an interesting one. It's called Google Magic Eraser. So given this kind of input image, the goal of this task is to remove the background unwanted objects like this. So we will have this kind of figure in the end. So that is so-called image imprinting task in our computer vision domain. So in order to build up this kind of computer vision models, we may utilize different types of algorithms from machine learning or deep learning. So we design such a model and train this model with lots of data with the labels to have our final results. So here I will introduce my previous research done in my PhD. So the first one is a cultural heritage project, which was sponsored by Belgian government. So in that project, we built an automatic tool to recognize and transcribe these music manuscripts from the Renaissance period. So we utilize different types of techniques from image processing and machine learning and so on. So like we remove the staff lines from the manuscripts, we do the segmentations for these symbols, and finally we do the classification. And after that, we can transcribe all the information into the modern notation with its MIDI outputs. So more information can be found in this publication if you are interested in. Another type of project I have been working on is related to autonomous driving. So that project was sponsored by Toyota Europe. In that project, I was mainly working on the image semantic segmentation. So like I just introduced before, given this type of input image, and the goal of this task is to predict the pixel-wise class label like this. So we design the model, or say the network in between, to let the image going through this network and finally predict the pixel-wise class label like this. So previously, I have been working on different types of methods to improve the performance of this task. The first one is called error correction model. That is a post-processing method for this task. So we design a model to refine or correct the errors from the segmentation results from any semantic segmentation model. So further details can be found in this publication. So as you can see that our results works better than other competing methods, which is more closer to this ground truth label. And the second work I would like to introduce is model selection. So in that method, we combine the advantages from different models, like a fast model and an accurate model, to make it more accurate and faster. So as you can see from the result over here, so we have our model selection result in this figure D, which is the combination of the figure C and figure F, where figure C is a fast model and figure F is an accurate model. You can see that from this region, our model successfully selects the right part from the accurate model so that it looks similar to this ground truth label. So here comes our current topics. So we are currently working on fast inferences, like we are utilizing the NVIDIA Jetson boards to do the fast inferences for different types of computer vision tasks, like depth estimation or semantic segmentation. And another topic is called continual learning or online learning. So it's like adding new type of class into our current model setting. So we want to improve the learning of different classes. So in order to join our lab, you may require this kind of skills, like you must be good in programming, or you may have good mathematics skills. That means you are not afraid of reading the equations from the papers, and you need to have good communication skills and be creative. So after getting to this research domain, here are some possible future career plan for you guys. So it is possible to join this type of big companies like TSMC, NVIDIA, Microsoft, Google, and so on. So if you would like to know more details or ask any questions, so feel free to scan this QR code to reach my personal website, and you will find my contact info there. Thank you for your attention.